The vertices of a triangle are origin 0, 0, a 0 and b 0, b. Write the coordinates of its circumcenter. Also write the distance between the circumcenter and orthocenter. So clearly if we can see the vertices, it forms a right angle triangle. So origin vertex a, 0 on x-axis and vertex b on y-axis 0, b. Let us consider. So clearly it's a right angle triangle at origin. Circumcenter. Since we know that in a right angle triangle, circumcenter of a triangle, circumcenter of its or its circumcenter will be the midpoint of hypotenuse. Its circumcenter is the midpoint of hypotenuse of right triangle. So here hypotenuse is AB, so the midpoint of AB is the circumcenter. Therefore, circumcenter is equal to midpoint of AB. So A is the point A, 0 and B 0, b. Since we know the midpoint is for any 2 points x1, y1 and x2, y2, the midpoint is x1 plus x2 by 2, y1 plus y2 by 2. x1 plus x2 by 2, y1 plus y2 by 2. So here a, 0 and b 0, b. So we can write a plus 0 upon 2, 0 plus b upon 2. So which is a upon 2, b upon 2. This is the circumcenter. Also, in a right angle triangle, the orthocenter will be the vertex where right angle forms. So here origin is the orthocenter. Orthocenter of a right angle triangle orthocenter of right angle triangle is the vertex where right angle forms. So therefore, orthocenter of triangle OAB, orthocenter of triangle OAB, which is equal to origin, we can consider, because in triangle OAB angle O is 90 degrees. So we can consider origin 0, 0 is the orthocenter. And now we need to find the distance between the circumcenter and the orthocenter of triangle OAB. Circumcenter is a by 2, b by 2 and orthocenter is 0, 0. Let us find the distance. Now the distance between circumcenter a by 2, b by 2 and orthocenter origin 0, 0 is distance formula using under root of x2 minus x1 whole square. So we can write here a by 2 minus 0 whole square plus b by 2 minus 0 whole square, or we can write 0 minus a by 2 whole square plus 0 minus b by 2 whole square also we can write. So which is equal to under root of a by 2 whole square is a square upon 4 and b by 2 whole square is b square upon 4. So which is equal to a square plus b square upon 4 under root or we can simplify and we can write root over a square plus b square upon square root of 4 is 2. So therefore the distance between circumcenter and orthocenter of triangle OAB, let me write here, of triangle OAB is root of a square plus b square upon 2. Okay, correct. Please like, share, subscribe and support us. Thank you. Write the coordinates of the orthocenter of the triangle formed by points 8, 0, 4, 6 and 0, 0. Let us consider the points to be A 8, 0, B 4, 6 and say origin 0, 0. And now let's check whether this triangle is a right angle triangle or not first. So by taking their slopes, slope of AB, it's a y2 minus y1 upon x2 minus x1. It's a 6 minus 0 upon 4 minus 8, which is equal to 6 upon minus 4, which is equal to minus 3 by 2. And now slope of BC, slope of BC is 0 minus 6 upon 0 minus 4, which is equal to 6 upon 4, which is 3 upon 2. And slope of AC, we can write CA, sorry, this is origin BO, and this is OA. Third point is O. Slope of OA is equal to 0 minus 0. So it's a 0 upon 0 minus 8, we are getting 0. And we can see clearly that based on the slopes, we can say none of these sides are perpendicular. So it is not a right angle triangle. And hence, now let us find the circumcenter and centroid to find the orthocenter. So which helps us easily to solve. So let's find the circumcenter. Circumcenter of triangle OAB. Let the circumcenter be of triangle OAB be Px, y. Let's take the point C, circumcenter Cx, y. Then, since we know that circumcenter is equidistant to all the vertices, so CA is equal to CB is equal to CO. The distance must be equal, which implies that CA square is equal to CB square is equal to CO square. I'm squaring. Then by using the distance formula, CA square is nothing but x minus 8 whole square plus y minus 0 whole square, and CB square is x minus 4 whole square plus y minus 6 whole square, which is equal to CO square is x minus 0 x square plus y minus 0 y square. So let us solve this. Let me consider this both first and let me take the first and the second one. So we have x minus 8 whole square plus y square is equal to x minus 4 whole square. Let me consider x, better to take first and the last. X minus 8 whole square plus y square is equal to x square plus y square. So here y square gets cancelled, and on simplifying, x square minus 2 8s are 16x plus 64, which is equal to x square, or here again we can cancel this x square, and we have 16x is equal to 64 or x is equal to 4. So we got x coordinate is 4, and now let us simplify by taking the second and third. Now from the second and third, x minus 4 whole square plus y minus 6 whole square is equal to x square plus y square. So let us substitute x is equal to 4, 4 minus 4 0, and y minus 6 whole square, which is equal to x square, that is 4 square is 16, 16 plus y square. Down simplifying, we can add y square minus 12y plus 36 is equal to y square plus 16. So again y square gets cancelled. So here 12y is equal to 36 minus 16, that is 20. So y is equal to 20 upon 12, or 4 5s are 4 3s are. So y coordinate is 5 by 3. Therefore circumcenter is equal to C 4 comma 5 by 3. And now centroid. Centroid of triangle OAB. Since we know centroid of triangle is x1 plus x2 plus x3 by 3, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So the three vertices are 8 comma 0, 4 comma 6 and 0 comma 0. So let me write. So which is equal to, x coordinates are here 8 plus 4 plus 0 upon 3, comma y coordinates are here 0 plus 6 plus 0 upon 3. So we have centroid. Let us consider a G is equal to 8 plus 4, 12 upon 3, that's 4, and 6 upon 3, it is 2. So we got centroid 2. And now we know that centroid divides orthocenter and circumcenter. Orthocenter or circumcenter in the ratio 2:1. So that is, if O is orthocenter, G is the centroid, and C is the circumcenter. So centroid is dividing the orthocenter and circumcenter in what ratio? 2:1 ratio. Or you can just remember, for shortcut, you can written here N ONGC. ONGC, if you can remember. So O to G, here two parts are there. So 2, and G to C, it's one part. So 2:1 ratio, you can remember. Okay. Now let us find this orthocenter by using this. So let orthocenter is alpha comma beta, and the centroid is known 4 comma 2, and the circumcenter is known 4 comma 5 by 3. And now by using the section formula, the ratio is given 2:1. So we can write 4 comma 2 is equal to the centroid 2 times of mx2 plus nx1, by using the formula mx2 plus nx1 upon m plus n, and my2 plus ny1 upon m plus n. So we can add 2 times of 4 plus 1 times of alpha upon m plus n, that is 2 plus 1, and m times of, that is 2 times of 5 by 3 plus 1 times of beta upon 2 plus 1. And on simplifying here, 8 plus alpha upon 3, 8 plus alpha upon 3 is equal to 4, comparing the coordinates, and this is 10 upon 3 plus beta upon 3 is equal to 2. So which implies here 8 plus alpha is equal to 12, alpha is equal to 12 minus 8, that's 4, and 10 upon 3 plus beta is equal to 6, or we can add beta is equal to 6 minus 10 upon 3, that is 18 minus 10, 8 upon 3. So we got alpha and beta, therefore we can mention, therefore orthocenter of given triangle is 4, 8/3. Okay. Please like, share, subscribe and support us. Thank you. Three vertices of a parallelogram taken in order are -1, -6, 2, -5 and 7, 2. Write the coordinates of its fourth vertex. Let the three vertices of parallelogram be, say A -1, -6, B 2, -5 and C 7, 2, and let the fourth vertex be, and let the fourth vertex of parallelogram be, let us consider D x4, y4. Okay, and since we know that in parallelogram let's consider this a parallelogram A, B, say the C and D. If in a parallelogram x1, y1 and x2, y2 and x3, y3 are the three vertices and the fourth vertex is x4, y4, then we have this x4, y4 vertex, we can write it as sum of the, like x1 plus x3, its x coordinate is nothing but x1 plus x3 minus x2, y1 plus y3, y1 plus y3 minus y2. So this is one shortcut, we can use it just like a cross, a coordinate and c coordinate sum and then subtract the b coordinate. So x1 plus x3 minus x2, y1 plus y3 minus y2 will get the coordinates of vertex D, fourth vertex. Or we can use using the midpoint concept. We can use the midpoint concept. Midpoint of AC will be equal to midpoint of BD. So midpoint of AC is 7 minus 1 plus 7 upon 2, comma minus 6 plus 2 upon 2 is equal to BD midpoint is 2 plus x4 upon 2, comma minus 5 plus y4 upon 2. That is 7 minus 1, 6 upon 2, 3, comma 2 minus 6, that is minus 4 upon 2 is minus 2 is equal to 2 plus x4 upon 2, comma minus 5 plus y4 upon 2, and on simplifying you will get 2 plus x4 upon 2 is equal to 3 and minus 5 plus y4 upon 2 is equal to minus 2. So we can write here 2 plus x4 is equal to 6, 2 3s are, and here x4 is equal to 6 minus 2 is 4, and we can write here minus 5 plus y4 is equal to minus 4, or y4 is equal to minus 4 plus 5, that is y4 is equal to 1. So we got the coordinates, therefore fourth vertex of parallelogram is 4, 1. Even the same answer we will observe here also by taking the coordinates by using this shortcut also. x1 plus x3, so that is minus 1 plus 7 minus 2, comma minus 6 plus 2 y3 minus of minus 5. It's a 7 minus 1, 6 minus 2, it's a 4, comma minus 6 plus 2 is minus 4 plus 5, 5 minus 4, 1. So we got the fourth vertex 4, 1. Okay, so you can use For objective purpose, this shortcut trick. Conceptually, we can find by using the midpoint. Okay, right. Please like, share, subscribe and support us. Thank you. If the points a comma 0, 81 square comma 281 and 82 square comma 282 are collinear, write the value of t1 t2. If the points are collinear, we can say the points lying on the same straight line. So we can use the concept of slope concept, or you can use the area of triangle concept. Area of triangle ABC, where a x1 comma y1, b x2 comma y2 and c x3 comma y3, which is equal to half mod of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. If the points ABC are collinear, so which implies that area of triangle ABC will be equals to 0. So that we can consider x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2 equals to 0. So here the 3 points are given. Let us consider, say a comma 0, b 81 square comma 281 and c 8 t2 square comma 2a t2. Say this is x1 y1 and here let us consider x2 y2 and this is x3 y3. So here given ABC are collinear. So we can consider this condition. So from 1, so we can write here a times of y2 minus y3, that is 2a t1 minus 2a t2 plus x2, that is a t1 square of y3 minus y1, that is 2a t2 minus 0 plus c times x3 times, so that is a t2 square y1 minus y2, that is 0 minus 2a t1, which equals to 0. Or here we can take 2a common, so 2a into a, 2a square of t1 minus t2 plus here we can write this is 2a square t1 square t2 and here minus 2a square t1 t2 square is equal to 0. So 2a square of t1 minus t2 and here we can take out common 2a square, also t1 t2 common, so we can write here t1 minus t2 is equal to 0. So on the whole we can take 2a square of t1 minus t2 common and then the remaining is 1 plus t1 t2 which is equal to 0. So which implies a square of t1 minus t2 or 2a square of t1 minus t2 is equal to 0, or we can write 1 plus t1 t2 is equal to 0, and since a cannot be equals to 0 because all the coordinates will become origin, so a cannot be equals to 0, so we can say t1 minus t2 is equal to 0, or here we can write t1 t2 is equal to minus 1. So we can say either t1 is equal to t2 or t1 t2 is equal to minus 1. So here we require the value of t1 t2, so we can consider the answer to be minus 1. Okay, please like, share, subscribe and support us. Thank you. If the coordinates of the midpoint of the sides AB and AC of triangle ABC are 3, 5 and minus 3, minus 3 respectively, what is the length of the side BC? Let's solve this problem in two ways. So let us consider A, B, C. The midpoints of the sides, say AB is given, let us consider to be D, 3, 5, and the midpoint of AC is given, let's consider to be E, minus 3, minus 3. Now let us consider the midpoint of, let midpoint of BC be, say F, alpha, beta. So let us consider to be alpha, beta. Then we have the vertex of B can be taken. The vertex B can be taken as 3 plus alpha minus of minus 3, just like sum of these two coordinates, x coordinates, and take the difference of its opposite vertex, that is minus. So 3 plus alpha minus of minus 3, and again 5 plus beta minus of minus 3. It's a vertex B, that is 3 plus 3, that is 6 plus alpha, comma, that is 5 plus 3 here, 8 plus beta. And now vertex C we can write it as, using the same concept, vertex C we can write, now here we have to add these both x coordinates of these two coordinates and then subtract the opposite one. So that is alpha minus 3 minus 3, and again beta minus 3 minus 5. So we are getting the vertex C as alpha minus 6, beta minus 8. So this is the vertex C. And now the distance between these two, the length of BC is distance between these 2 points, x2 minus x1 whole square plus y2 minus y1 whole square. So we can write x minus alpha minus 6 minus of 6 plus alpha whole square plus y2 minus y1 whole square. That's a beta minus 8 minus of 8 plus beta whole square. So which is equal to, on simplifying, we can write alpha minus 6 minus alpha whole square, and here beta minus 8 minus beta whole square. So which is equal to, we can cancel alpha and alpha, here beta and beta gets cancelled. So minus 6 that is minus 12 whole square, and here minus 8 minus 16 whole square. So we have minus 12 whole square is 144 and minus 16 whole square is 256. So 256 plus 144 will give 400. So square root of 400 we can consider to be the length is positive, so BC is equal to 20. Therefore the side of the length of BC is, length of BC is 20 units. So this is one way, and now let us solve by another concept, by using the midpoint theorem concept. Let's consider the same. ABC are the vertices and the midpoint of AB is D, 3, 5, and the midpoint of E is given minus 3, minus 3. Since we know that the line joining the midpoints of any two sides of a triangle, AD and DB are equal and AE and EC are equal, then the line joining the two midpoints of two sides is parallel to the third side and also half of it. That is, DE is parallel to BC and the length DE will be equal to half the length of BC. And since we know the length of the vertices of D and E, so the distance between D and E can be found, which is equal to under root of x2 minus x1 whole square minus 3 whole square plus y2 minus y1 whole square, that is minus 3 minus 5 whole square. which is equal to under root of minus 3 minus 3 minus 6 whole square, and here it is minus 3 minus 5, it's minus 8 whole square. It's a 36 plus 8 square is 64, so 36 plus 64 is 100, square root of 100 is 10. So therefore the length of DE is equal to 10 units, and since we know that it's a DE, the length is half of the length BC, or BC is equal to 2 times of DE. Therefore BC is equal to 2 times of DE, which is equal to 2 into 10 units, that's a 20 units. And hence we can say the length of the side BC is, hence length of side BC is 20 units. Okay, both the ways you will get the same answer, right? Please like, share, subscribe and support us. Thank you. Write the coordinates of the circumcenter of a triangle whose centroid and orthocenter are at 3, 3 and minus 3, 5 respectively. Given centroid of triangle, say ABC, is 3, 3, and orthocenter let us consider O of the same triangle ABC is minus 3, 5, and let the circumcenter be, let the circumcenter of triangle ABC be C, say alpha, beta. And since we know that centroid of a triangle divides the line joining orthocenter and circumcenter in the ratio 2:1. Or you can just remember orthocenter is O and centroid is G and circumcenter is C. The centroid is dividing orthocenter and circumcenter in the ratio 2:1 as by taking n here. N is a point, ONGC you can remember. So OG is divided into 2 parts, here 2 parts, and GC is 1 part. So centroid is dividing orthocenter and circumcenter in 2:1 ratio, where n is also represent the 9-point center. Okay, now let us see this. Let's find, and here orthocenter is given. Orthocenter is minus 3, 5, and centroid is given 3, 3, and let us given circumcenter be alpha, beta. So let us solve this. So we have 3, 3 by using the section formula, mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n, which is a formula for centroid. So 3, 3 is equal to mx2, so m is equal to 2, so 2 times of alpha, 2 into alpha, plus 1 times of minus 3 upon m plus n, 2 times of beta, plus 1 times of 5 upon m plus n, that is 2 plus 1. So we have 3, 3 is equal to 2 alpha minus 3 upon 3, 2 beta plus 5 upon 3. So we have 2 alpha minus 3 upon 3 is equal to 3, and 2 beta plus 5 upon 3 is equal to 3. 2 alpha minus 3 is equal to 3 3s are 9. 2 alpha is equal to 9 plus 3. So alpha is equal to 12 upon 2. So alpha is equal to 6. And here 2 beta plus 5 is equal to 3 3s are 9. And 2 beta is equal to 9 minus 5. So beta is equal 2 beta is equal to 4, or beta is equal to 4 upon 2, so which is equal to 2. Therefore circumcenter alpha comma beta, circumcenter C alpha comma beta is equal to 6 comma 2. So 6 comma 2 is the answer, right? Please like, share, subscribe and support us. Thank you. Write the coordinates of the incenter of the triangle having its vertices at 0, 0, 5, 0 and 0, 12. Since we know that the coordinates of the incenter of a triangle whose vertices are say A x1 comma y1, B x2 comma y2 and C x3 comma y3 are given as ax1 plus bx2 plus cx3 upon a plus b plus c and ay1 plus aby2 plus cy3 upon a plus b plus c, where a is equal to side bc and b is equal to side ca and c is equal to side ab, the length of side ab. Okay, now here in this triangle vertices are given. Vertices are say a 0, 0, b 5, 0 and c 0, 12. So clearly it is one of the origin and the vertices on axis, coordinate axis. So it's a right angle triangle. So easily you can find the length of the sides. So this is the point A 0, 0 and here is the point 5, 0 and C is the point here 0, 12. So easily we can say that the length of AB, so whereby A is equal to the side length BC. BC is equal to the distance between B and C is 5 minus 0 whole square, that is 5 square, plus 0 minus 12 whole square, that is 12 square. 144 plus 25 is 169. Square root of 169 is 13 units. The length of A is 13 units. And then B is equal to the distance CA. CA distance is on y-axis, so it's from the origin to 12 units. So we can say directly 12 units. And C is equal to AB. So AB distance is on x-axis, so the distance is 5 units from origin, so we can say 5. So we got A value, B value and C value. Now let us substitute in the formula. Therefore incenter of triangle ABC is equal to AX1, that is 13 times of x1 is 0. Say these are the x1 y1, this is x2 y2 and third coordinate x3 y3. So 13 into 0 plus b into, that is 12 into x2, x2 is 5 plus c times of, that is 5 times of x3, x3 is 0 upon a plus b plus c, that is 13 plus 12 plus 5 and the next coordinate a times of, that is 13 times of y1, it's a 0, plus b times of, that is 12 times of y2 is again 0, and c times of, that is 5 times of, and y3 coordinate is 12 upon 13 plus 12 plus 5, so which equals to, so it's a 12 5s are 60 upon 13 plus 12 25 plus 5 30, comma, and here again 12 5s are 60 upon 60, sorry 30, so 60 upon 30 is 2 and 60 upon 30 is 2, so we can give the answer 2 comma 2. So the incenter of triangle ABC is 2 comma 2. Okay, please like, share, subscribe and support us. Thank you. If the points 1 comma minus 1, 2 comma minus 1 and 4 comma minus 3 are the midpoints of the sides of a triangle, then write the coordinates of its centroid. So let's consider a triangle. Let us consider the vertices of triangle is ABC and the midpoints are given, say D, given midpoints D1 comma minus 1 and E 2 comma minus 1 and F 4 comma minus 3. Of triangle ABC. So let us consider this triangle ABC. And now the lines joining the midpoints, the lines joining the midpoints is again a triangle. And the centroid of triangle DEF, so which is equal to centroid formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So we can write here 1 plus 2 plus 4 upon 3 and minus 1 minus 1 minus 3 upon 3, which is equal to 7 upon 3 comma minus 5 upon 3. This is centroid of triangle DEF, but we need the coordinates of centroid of triangle. Since we know that centroid of triangle formed by the midpoints is same as the centroid of the original triangle. That is, centroid of triangle DEF is same as centroid of triangle ABC. We can write centroid of triangle ABC is same as centroid of triangle formed by the midpoints. That is centroid of triangle DEF. So what is centroid of triangle DEF? 7 upon 3 comma minus 5 upon 3. So we can give the answer 7 by 3 comma minus 5 by 3 is the answer. Okay. Please like, share, subscribe and support us. Thank you. Write the area of the triangle having vertices at a comma b plus c and b comma c plus a and c comma a plus b. Let the vertices of triangle say ABC be a comma b plus c, b comma c plus a and c comma a plus b. So we have delta is equal to half x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2 if the three coordinates of triangle ABC are x1, y1, x2, y2 and x3, y3. So which is equal to half. So area of triangle ABC can be taken half x1, that is a times of y2 minus y3, that is c plus a minus b, plus x2 of, that is b times of y3 minus y1, that is a plus b minus c, and plus c times of y1 minus y2, that is b plus c minus a. So which is half of a times of, so we can write here c minus b plus b times of a minus c plus c times of b minus a. And on simplifying, half of, this is ac minus ab plus ba minus bc plus cb minus ca. So we can cancel here plus ac and minus ac, and minus ab plus ab, and minus bc plus bc. So we will get 1 by 2 into 0, which is 0. Therefore area of given triangle is 0 square units. Okay, please like, share, subscribe and support us. Thank you.